Hi guys, so let's recap a bit on the concept of limiting reagent. So let's take an example. Let's say we're making pie, and for us to be able to make pie, we need 2 apples and 1 pack of flour to be able to make 1 pie. So let's say we have 4 apples and 1 pack of flour. Because we have 1 pack of flour, we would still be able to make only 1 pie, which means that we have 2 apples extra. 2 extra apples, which means that the apples are in excess here and that the flour is limiting the number of pies that we can make. Even if we had 100 of apples and 1 pack of flour, we would still be able to make only 1 pie. On the other hand, if we had 4 apples and 6 packs of flour, so each 2 apples, so the ratio of apple to flour is 2:1, which means that 4 apples will require only 2 packs of flour, which means that we have an excess of 4 packs of flour. So, which means that we would only be able to make 2 pies. So in this example, it's the apple that is limiting the amount of pies that we can make. So similarly, when we are having a reaction, when especially you have been given the mass of both reagents, both reactants, there's generally one of them which is in excess and one which is limiting the reaction. So whenever you are given the mass or the number of moles of both reagent, find the limiting reagent before you start any process. So let's see how we do this one. So we have the mass of magnesium and we have the mass of hydrochloric acid. So we'll go ahead and find the number of moles of magnesium and number of moles of hydrochloric acid. So here we have the number of moles of each one. What we'll do next is, so this is the calculation. So from the equation, so magnesium is to HCl, the mole ratio is 1:2. I will write the number of moles of magnesium that I have, 0.05. Number of moles of HCl, 0.075, and I will divide by the mole ratio. Divide by 1, divide by 2. So when I did this is the smallest value. So because it is the smallest value, we're going to say that this is the limiting reagent, which means that HCl is limiting. And so HCl is limiting and that magnesium is in excess. Now let's see the second example. So again, we have the mass of both. So we're going to go ahead and find the number of moles of this and the number of moles of this. And we'll use the mole ratio to find which one is going to be the limiting. So we've got the number of moles, mass divided by mol values. And we went ahead and wrote the mole ratio of the 2. And I'm going to write the number of moles of each one of them. So 0.1, and it's a coincidence that both of them have the same number of moles. But let's divide by the mole ratio. So 0.1 and 0.05. You see, this one is the smallest value, which means that this is limiting. Right, now because this is limiting, whenever we're going to go ahead for any calculation, we are going to use the number of moles of the ethanoic acid. And remember that when we are using the number of moles of ethanoic acid, we are going to use here, number of moles is mass over mR. This is what we are going to use. Do not use any values that you get from over here, from this calculation, from the side calculation to find the limiting. Do not use any of these values. So this is why I did that as a rough work. Okay, so I'm going to use the number of moles of ethanoic acid to calculate the number of moles of hydrogen gas. So from the equation, 2:1. So that's the mole ratio. Okay, and the number of moles of CH3CO which I have is 0.1. So half of this is going to be 0.05. So the number of moles of hydrogen gas produced is 0.05 from the mole ratio. Volume of hydrogen gas, remember that 1 mole of any gas occupies 24 dm cube. So the volume of hydrogen gas or any gas would be 0.05 times 24. So that's the volume of hydrogen gas. Now let's see past exam paper questions. So in this question, you're given the number of moles of silicon and you're given the mass of bromine. So number of moles has been found, but you are given the mass. And for you to find the limiting reagent, you will need to convert that mass to number of moles. Now it tells you explain your choice. Now your calculation can be used as an explanation for your choice. There is no need to write a lot of words. The lines will be used to show your workings. So here I've calculated the MR of bromine, 160. So bromine exists as Br2, so 2 times 80. So number of moles is mass divided by MR. And I'm going to use the mole ratio now. Silicon is to bromine, so this is 1:2, and 0.07 is to 0.156. I'm going to divide this by 2, divide this by 1, and I'm going to have these two values. So from the two values, I find that this is the smallest. So smallest. Therefore, SI is limiting. Here you go. So SI is limiting reagent. So that would be the explanation. There is no need to write a lot. So that's for 3 marks. So you will get 1 mark for saying that SI is limiting. You would get 1 mark for calculating the number of moles of bromine, and you would get 1 mark for using the mole ratio and getting the values of number of moles of each one. So how many moles of the silicon bromide is formed? So it will depend on the number of moles of silicon, because this is the limiting reagent. So when I'm going to find that, I'm going to use the mole ratio silicon is to silicon bromide, and you see here it's 1:1. So if you have 0.07, it's going to give you 0.07 moles of silicon bromide. So I'm just going to write the value here. So that's 1 mark. The second question, so there is one piece of marble, and marble, in case you didn't know, marble is calcium carbonate, and this was added to 5 centimeter cube of hydrochloric acid. So this is the volume, and it's in centimeter cube, so you will need to convert that to dm cube to use it. And this is the concentration. So from concentration and volume, you can find number of moles. So which reagent is in excess? Give a reason for your choice. Now, the examiner has already broken down the question into different parts. So here it's telling you the mass of 1 mole of calcium carbonate. Mass of 1 mole is the molar mass. And molar mass, as you know, is the MR. So the MR of calcium carbonate has already been given. You know the mass of calcium carbonate. So the number of moles is mass divided by MR. So 0.3 divided by 100. That's the number of moles of calcium carbonate. Now, number of moles of HCl is concentration times volume. Concentration is 1, volume is 5 centimeter cube. So if you convert that, it's 5 divided by 1000. So let me just put it like that. 5 divided by 1000. That's going to give me, here you go. Now, for you to know which one is in excess, remember that you need to use the mole ratio, but the equation is not given. So you will have to write the equation. So calcium carbonate plus hydrochloric acid. Carbonate plus acid gives salt plus water, plus carbon dioxide plus water. Make sure you write the equation well. So calcium chloride is like this, and I'm going to put 2 here. So the mole ratio is 1:2. So let me write 1:2. For calcium carbonate, I have 0.03. And for HCl, I have 0.005. I divide by 2. So 0.003 and 0.0025. So you see that this one is smallest, which means that HCl is limiting. So that's the working, and you can just give your answer here. So HCl is limiting, which means that this is in excess. So this is limiting, therefore this is going to be in excess. So in excess is calcium carbonate, or you could say marble. Reason, because you have more moles of calcium carbonate than the number of moles of HCl. So this is my answer. The amount of calcium carbonate is more than what is required to react with 0.05 moles of HCl. So 0.05 moles of HCl will require half of it, which means only 0.025 moles of calcium carbonate. But we have more than this available. We have 0.03 moles of calcium carbonate, which means that this is in excess and this is in small amounts. And use your answer in 2 to calculate the maximum volume of carbon dioxide. So the volume of carbon dioxide will depend on the reagent which is limiting. So it will depend on the number of moles of HCl. So from the equation, HCl is 2, carbon dioxide is 2:1. So you see 2:1 here. And I have 0.005 moles of HCl. This will react with 0.0025 moles of carbon dioxide. So this is moles. The question is asking me for volume. Volume is number of moles times 24. That gives me 0.06 dm cube. Okay, here you go. Question 3 now. So define the mole. So I had already given you the definition of the mole. So it is the amount of substance that contains the same number of particles as the Avogadro's constant, which is 6.03 times 10 to the power of 6.02 times 10 to the power of 23. The second part, so you have the mass of magnesium, you have the mass of ethanoic acid, and you need to find which one is in excess, and you need to show your reasoning. So you see, again, it's 3 marks, just like this one, 3 marks. So you will need to find the number of moles of each one. So here, mass of 1 mole of Mg is given. So this is the molar mass, which is the MR, or in this case, it would be the AR here. And mass of 1 mole of ethanoic acid. So this is the MR. This is already given, so no need to go and calculate it. So I've calculated the number of moles, mass over AR. Here, mass over MR, I've got the number of moles. From the equation, I've got the mole ratio, 1:2. So I'm going to fill in over here and divide by the mole ratio. And as you can see that this is smaller value, which means that this is limiting. And the question asks you which one is in excess, which means that you're going to say that magnesium is in excess. So there is more Mg than required to react with 0.2 moles of ethanoic acid. So 0.2 moles of ethanoic acid requires only 0.1 mole of magnesium, but I have 0.125 moles of magnesium, so I have more here. So this is in excess. So here you got the answer. So for 3 marks. Sulfur dioxide reacts with chlorine to form sulfuride chloride. So this is a sulfuride chloride, and it tells you that 8 grams of sulfur dioxide reacted with 14.2 grams of chlorine, and the mass of 1 mole of sulfuride chloride is given. So mass of 1 mole, so this is the MR of SO2Cl2. You need to calculate the mass of sulfuride chloride formed by this mixture, and it has been broken down into the different parts of that question. So you are given the mass of sulfur dioxide and the mass of chlorine, so definitely means you will need to find the limiting reagent. So calculate the number of moles of SO2. Number of moles is mass divided by MR. So the MR of SO2, if you calculate it properly, you should have 64. So the number of moles is mass divided by MR, and that gives you 0.125 moles. And the number of moles of Cl2, again, it will be mass divided by MR. So the MR of Cl2, if you do it properly, you should have 2 times 35.5, that's 71. So that would be 14.2 divided by 71. That gives you 0.2. Now, which reagent was not in excess? Be careful here. So from the equation, it's 1:1. So SO2 is to Cl2, 1:1. So 0.125 is to 0.2. Divide by 1, so you would still get that same value. And from this, you see that this is smallest, which means that this is limiting. So SO2 is limiting, and which is not in excess means which one is limiting. So SO2 is not in excess. How many moles were formed? So the number of moles of the product is determined by the number of moles of substance which is limiting. So it's 1:1:1, so it will be 0.125 moles of product. And the mass form, so mass would be equal to number of moles times MR. So 0.125 times the MR of that compound, which has been given as 135. Okay, so this is the value, and here I'm giving the answer. Either you can give it this the complete value, because it's a complete number. It's not an irrational number, so you can give that value, or I've chosen to write it as 16.9 grams, because if you look at the values of mass given here, so this is given to 1 dp, again to 1 dp, so I'm giving my final answer to 1 dp, because it's so gram, so 1 dp, so I'm giving my answer to 1 dp. That's one way of looking at it. Okay, so that's it for all the questions on limiting reagent.